The fundamental theorem of calculus is a big idea in AP calculus. And the fundamental theorem of calculus involves two parts. One part is the fact that the derivative and antiderivative will undo each other. So if I take the antiderivative of f of x and differentiate it, I'm back to f of x. The other part of the fundamental theorem of calculus is the area under the slope curve, or the area under the derivative, is the displacement on the antiderivative function. So here we have f of x in the integral. That represents the derivative of big F, and the displacement on big F represents the area underneath that derivative function. Now, this idea we have to be able to apply in different ways. So in the context of tabular values, when we're using functions, when we're dealing with functions, and when we're dealing with notation. So sometimes we have to differentiate notation. One of the big ideas that you'll see on the AP exam is this idea that the y-coordinate can be found from area. But to do that, we need a starting point. So the f of a represents a starting point. We need to have a start. So this is going to represent, so that's going to represent the starting value, f of a. Okay, so that's the starting value. And that value is going to start some x-coordinate a. So that a in the integral has to represent where that coordinate is defined. And then we're going to add on to that from the starting coordinate, we're going to add on the change in the f. Okay, so the area under the derivative is going to represent the change in the antiderivative. So if we have some starting y-coordinate and we find the change in the y-coordinates, we'll end up with a new y-coordinate f of x. Example 1 is an AP exam question from 2012. It says a tank contains 50 liters of oil at t equals 4 hours. The oil is being pumped into the tank at a rate, so R is a rate function, where RT is measured in liters per hour and T is in hours. So we have selected values of R in the table, and using a Wright-Riemann sum with 3 subintervals, what is the approximation for the number of liters of oil in the tank at 15 hours? So we want to find the number of liters, and that is on the antiderivative of the rate function R of t. So we can do this by having our starting point, which is 50 liters at t equals 4. So notice that the 4 is the beginning of our interval, up to t in the area under the R of x function. Okay, so what we want to do then is we want to calculate the liters at 15 hours. That's going to be equal to the starting value of 50 plus the area under the curve from t equals 4 that's our starting point, to t equals 15 underneath our rate function. Okay, so we need to then find out the area under that rate function. So we're going to use these Wright-Riemann sums. For the first rectangle, we have the height is going to be 6.2, the width is 3. We end up with 18 liters. Sorry, 18.6 liters. In the second interval, it's 5-hour interval, and the height is 5.9. So we end up with 29.5 liters. And in the last interval, we have 3 hours, 12 to 15, and a height of 5.6. So we end up with 16.8 liters. And summing that all up, we're going to get 64.9 liters. So working out the liters at 15 hours, it's going to be equal to 50 liters plus the area under that curve, or the area under the Riemann sums, is going to be 64.9 liters. And that's going to give us a total amount of liters of 114.9 liters. So that is going to be our approximation. So it looks like C is the correct value for this problem.